My name is Midori Kawaguchi, and I'd like to talk to you about an application that supports archery players' practice. So, have you ever tried individual sports like batting, golf, shooting, and archery? These individual sports have high repeatability as high as the level of experience. It is important to be aware of how players moved during playing sports. But there are 2 points to pay attention. First, if the players repeat a long movement many times, their body would remember the long movement. And second, the best form of sports movement depends on individual physical characteristics. There are many tools for check self-sports movement to make their performance better. Chronophotography, oh, sorry, chronophotography, angle of joints, and trajectory can be checked in video system. Motion capture and Kinect are often used to check movement, and their SCAD system is for shooting, can show fluctuations during aiming. Now I focus on archery as sports movement in my research. Archery has two characteristics. First point is that the shooting poles are different depends on the person. For example, they are player to players, and the angular velocity of shoots looks different. And second point is that high-level archery players have high repeatability in shooting poles. If they take mistake during shooting, you can find out different angular velocity wave. There are many studies for make archery training better. These are tools for visualize information or posture. It is good for a beginner. Check the condition of shoots one by one. But they are not useful for experts because of comparing between shoots is difficult. It is able to compare, but it is basically a one-to-one comparison. It takes time in the case if they want to compare many shoots. To realize safe body movement during sports training is important for improvement. Usually, sports players find a part they needed to make better by subjective judgment. But sometimes subjective judgment is incorrect. There are many tools for check their body movement, sensing, and visualize. It is useful for check every trial in detail. However, it takes time and labor if we want to understand in a big picture or comparing. Here's a proposal. What I want to do in this research is proposing the helpful way to check and analyze the movement data. Big 2-point make efficient comparison is first, clustering all shoots in one player. Shoots in the same cluster have similar features. And second, in two-shoot comparison, comparing, the different part will be highlighted like this. Players can search the part to pay attention by using this system. So this is overview of how the system works. There are 4 phases. The first is sensing. The system measures angular velocity of the ball. Next is preprocessing. It split each shooting movement into 3 phases and remove the effect of the natural vibration by FIR filter. Then, the clustering makes all shoots into several clusters by using k-means method, with a distance measure of DTW or DP matching. Finally, it shows graphs and videos in visualization. Only angular velocity is used for clustering. Videos, scores, and subjective rating and impressions are also took and shown in visualization. From the next, I'll explain the system in this order. So let's start from sensing. Here's the detail of angular velocity sensor used. The sensor put it on the ball like this. And be careful for sounds. This is a movie. This is my shooting movie and angular velocity change of the shot. There are three phases in one shot: draw the ball, aim, and release the arrow. After sensing, every shooting data are spread to three phases because of aim phase. It's less movement, and it is difficult to see small movement. Angular velocity time series data are subjected to an FIR filter to remove the effect of natural vibration of the ball. Dynamic time lapping is a method to evaluate the similarity between two different time series data. It is DP matching method for time series data. This method able to calculate the distance with considering stretch and match between two time series data. Different length data can be compared by using this. K-means method is used for clustering. This method required average of each clusters to define the best clusters. So dynamic time lapping by center average method is used. I will explain later. The number of clustering K is determined by using elbow method. So here is a method of calculate the centroid of time series data. There are two time series data, and this is average of the data of sequence A and B. But it can be generated average from several data in actual. When generating the average data of time series data of a group, the first time series data as a temporary centroid is input firstly. Secondly, matching pair of data between centroid data points and time series data points are set. It is the same way as in DTW. The centroid is made smooth by updating the data points for 4 times. Here is a figure of data measurement setup. Sensing is not only angular velocity, but movies from the two direction, subjective rating, and impression, and score are taken every shot for information for remember the shot. Now from here is visualize part. It is visualization output of one player's all-shoot clustering. The output is automatically made by GraphBits tool. So this is demonstration that how to get this output. This is visualized output of centroid comparisons. Here, a blue wave means the distance between centroid and centroid of clusters. A part of cost high, it means there are big difference. So this is demonstration. There are two clusters, and this is a distance between two clusters. and this blue wave means cost between clusters. And when you want to compare two shoots, this output will be easiest to understand. This shows visualization comparison between shoot alpha and shoot beta. A part of high different cost shows big difference part between two shoots. The IDs are assigned centrally from the largest score, the largest cluster. And this number shows the order of the distance from the centroid. The smaller it is, the smaller the number, the closer it is to the centroid. And the score, subjective rating, comments are shown to remind the shot and feeling. And there are buttons for check each shoot videos. On this button, you can check overlay video part with the largest difference. So this is demonstration of this application. A two shoot can be compared by choosing cluster ID and the order of the distance from the centroid. And you can choose the time to watch. And from this button, you can get overlaid movie that only the big difference part. Archers and an instructor were interviewed. In the interview, first, the system was explained. Then, the visualization of the shoots was shown to them, and next, they were allowed to try the system by themselves. And finally, they were interviewed. I'd like to show an example of differences found with the system. The difference is that shot alpha has two peaks on y-axis, and shot beta have only one peak. It means in this shoot, the archer stretched his arm twice, and in another shot, he already finished stretching his arm before bringing up his bow. And this is overlaid movie that detect different part. Here are shots in same cluster. It can show the shots in the same cluster have common feature. In this shot, in the same cluster, the yellow wave, it means angular velocity of y-axis have two peaks here. In a shot from another cluster for comparison, there are only one peak in the same part. There are four big types of detect differences in this system: continuous or not continuous, non-noisy or noisy, and length of operation time, and difference in speed of operation. Here are some comments from an archery instructor. In his opinion, this system is helpful for archery practice better. Making repeatability high in archery is important. Found difference is variable even if the difference is small. Found differences can show which movement the player should focus on to make better. In the case, the player did not do it on purpose. Visualization of output works good for him. In addition, he said that self-used application and immediate feedback would make the system better. Here are comments from 5 archers. The system looks work good. Some archers say that the system detects differences that they did not notice. This time score and comments are only used for visualization. Some archers wanted to know the relationship between the score and the movement. They also wanted to know not only ball movement, but also body movement. Immediate feedback is also demanded from archers. In this research, the tool that is helpful way to check and analyze the movement data can be suggested. And here is future work. Thank you for listening.
Thank you very much. That was archery shots visualization by clustering and comparing from angular velocities of bows by Midori.